Good morning, dear Shem Stars. How are you all, students? I hope you all are well and safe at your home. Students, yesterday we have started with the chapter 5, that is complex numbers, and seen its introductory part. So today we are going to start with the topic of modulus and argument of a complex number. Modulus of complex numbers. So if our number is of the form z is equal to a plus b iota, then its modulus is denoted by z mod, and it will be calculated by under root of a square plus b square. So you can see here an example for that. Suppose our z is equal to 2 iota, then we have to find its modulus. So here first we find our a and b. Clearly our a is 0 because no real part is there, and b is equal to 2. So when we find its under root, that is 0 square plus 2 square, so that will be equal to under root of 2 square and is equal to 2. Next is the argument of a complex number. Suppose our complex number is of the form x plus iota y. Students, as you know, the real part of a complex number is plotted against the x-axis, whereas the imaginary part is plotted on the y-axis. So therefore, if our both numbers are positive, they will be plotted in the first quadrant by taking x as real and y as imaginary part. So argument of a complex number is that angle which that point makes with the positive direction of the x-axis. So here tan theta is equal to y upon x, or you can say angle is given by tan inverse of the imaginary part, that is y, over the real part, that is x of the number. So here is the figure which shows how we will consider the values of argument. Suppose our argument is coming out to be alpha. So for the first quadrant we will like it as such alpha only. For the second quadrant our argument reduces to pi minus alpha. In third quadrant that goes by minus pi plus alpha. And for the fourth quadrant its value is just minus of alpha. Here alpha is that value of tan that it actually takes for that particular number. The value of alpha will be calculated by considering tan of alpha is equal to imaginary part divided by the real part of the complex number given to us. Now let us understand how to find the argument of a complex number with the help of an example. Suppose our complex number z is given by minus 1 minus iota. So first we will compare it with x plus iota y. So clearly our x is equal to minus 1 and y is also equal to minus 1. So tan of theta, that is imaginary part over real part, that will be equal to 1. And students, tan take the value 1 at pi by 4. But here it is lying in the third quadrant. How? Because both the points are negative. So minus minus always lies in the third quadrant. So our angle theta will become pi plus alpha. So this implies theta will be equal to 5 pi by 4. Students, let us revise the topics that we have covered today quickly. The very first topic that we have covered today is the modulus of a complex number. In modulus of a complex number, we have found that if a number is given by a plus iota b, then its modulus is given by whole under root of a square plus b square, and modulus cannot be a negative number. After modulus, the second topic that we have covered today is the argument of a complex number. In this we have studied that if a number is given by x plus iota y, then its argument, that is tan theta, is equal to imaginary part over the real part, or we can say theta is given by tan inverse of y upon x. So students, your today's homework is just to revise what we have done in the class today. That's all for today, students. Do revise what we have done in the class today, plus do your homework also, and in case you have any query, please feel free to ask on the Google Classroom at any time. Take care and have a great day ahead, students.